Hello and welcome to Automate It, our weekly podcast here at Polymath Robotics. I, of course, am Stefan Oxmacher, and sitting across from me is a man repping a CES party covered in Japanese characters and cats, because he is, in fact, an Otano cat who was at the Otano Cast party. And who exactly are you, sir?
I'm the guy who stole the last t-shirt off that pile and still feel guilty about it, even though it's supposed to be a handout.
And even though they were begging for people to take them, but I've had one too many Twinkies to fit into any of the sizes that they had. This is our show, Automate It, where every week we talk about how to build robots, how hard it is to build robots, and generally goof around with the idea of robotics in general. We, of course, split our show into two segments. In the first, we play a game that kind of simulates what it's like to start a robotics company, where we arbitrarily pick a setting and a technology and then try to spitball a company around it. And then after that, we talk about a topic of interest. And this week, we're responding to a LinkedIn comment we got recently where somebody said, the best way to build a robot is hire a consulting firm. We're going to dive into how that works. So with that, Ilia, you ready to play the game?
Let's do it.
All right, so I'm going to draw a card here at random to figure out which technology we either have to use or can't use. Oh, and it looks like I just happened to magically, totally not fakely, draw a card for a technology that Ilia is a huge fan of, ultrasonic sensors.
Awesome. Lots of mixed feelings about this sensor. Great, so let's see. And I am totally also not rigging the deck and pulling out public pools as a location. So I think with ultrasonics, there's a couple of things we could do around the pool. The obvious one, if you've watched Love, Death, and Robots or have been to my Aunt Jean's house in Jacksonville, Florida, is a robot for actually doing pool cleaning. And that seems lame sauce to me. Even if your robot attains sentience, decides that life is not worth living and comes back into the robot basic form.
Yeah, I just don't think it's that interesting. I mean, I think I've seen that in a 15-minute bit before, and I don't need to talk about it for 15 minutes.
Favorite episode.
So what I think is growing up, going to pools every now and then, like the towels get left all about. You might like have a towel that you're lying on and you're sitting out in the sun. You hop in the pool to swim around. You get back and the towel's wet. It's no longer like a nice thing to be laying on after you've kind of dried out in the sun. So I feel like we should use a robot to swap out the towels from the chairs near the pool.
Is this the same robot we talked about last episode that takes 45 minutes to fold the towel?
I don't think it needs to fold the towels. It just needs to pick up the old ones and deliver the new ones.
All right. So pet peeve of mine. Can I add on to our scope here?
Of course.
Pet peeve of mine.
I mean, it's a robotic startup. Let's add scope.
I mean, that's definitely the right thing to do. So let's make it more complicated. Anytime you go to any one of these all-inclusive resorts or whatever, right?
Yep.
There's always some like old German couple who got up at 4 a.m.
Oh yeah,
to go put their towel on the thing, goes back to sleep.
Yep.
Comes around at noon. Yep. Nobody's been able to use that bench.
Yep.
So this robot has to go and chase those people away.
Well, I think what it could do is, if the logic is that like any towel without a person in it for greater than X number of minutes, it takes the towel.
Exactly.
And actually, what's great, the value of this product is it makes it impossible for those old Euro tourists to take the best seats at the pool, because like it's not a person who they can yell at and like complain to management over.
It's just a robot.
It's just, I'm sorry, the robot did it, but really, if there's no towel on the chair, we don't save the seat.
Here's our pitch, right? Our pitch to the resort is that you get more pool space per pool space, basically, right? Like you don't need 50 square foot per person, whatever the metric is.
Yeah.
Because the robot will use your space more efficiently.
Yeah.
Right? So there you go. So you don't need as big of a beachfront.
And so I think from like an actual moving the towels perspective,
yeah,
if the towels put onto us or put in such a way that like we can grab the folded towel easily, we can then just like dump that on the thing. That's easy peasy.
Sure. A human can put a stack of towels on us and we spit them out like Pez dispenser style, basically.
Yeah, that could work. Or frankly, we could go to some like, vending machine that gives us one towel at a time. For getting rid of the dirty towels, what I'm thinking we do is we just grab a corner of the soggy, wet towel and we drag it across the side of the pool. Because then we don't need to structure this relatively unstructured thing. And, we're kind of cleaning the ground by the pool all on the way by making it more slippery.
you're so fulfilling 2-year-old. I think you'd wear out towels much faster. Like just by
how long do you think these resorts keep these towels? There's only so many Euro tourists worth of suntan lotion that can go into them.
Yeah, I mean that's fair. You would really want like a small, low degrees of freedom arm to keep it cheap.
Yep.
Right. It just has to reach within a small amount. And if you grab the corner of the towel, you could drag it back. That's probably okay. Fine. Let's make it easy. That way you don't have to.
That's probably easier than bunching it up.
Yeah.
I mean, or if you could grab it and you could like roll,
twist it
into a ball.
Twist it.
Kind of like one of those rat tails that like from high school locker rooms that nobody loved, but everyone loved.
Well, the other thing you'd want to do is like, why do we want to use ultrasound here? Right? Is probably to detect people, because you'd above this you'd want a layer of logic that knows where the chairs are, knows where towels should or shouldn't be. You can't really know where the chairs are because the chairs are going to move, right? Like if I'm being honest, when I'm a 70-year-old German tourist, I'm not only going to put my 2 towels out for me and my wife, I'm going to like pull another chair nearby, and that's going to be like where I keep my book and whatever. And I need the Stefan exclusion zone around me because I don't really want to be close to people. No. So what this robot does, not only put it,
I'm like 70 years old. I survived the fall of the Berlin Wall. Like I need my space in this resort.
You know, like I survived the fall of the Berlin Wall. It's not that bit long ago. Anyway, so really, if we want to increase scope more, because again, we're a startup in robotics, so it's a healthy thing to do. The other task is rearranging the chairs themselves at night. Yeah,
I think that's outside of scope because I think like that's a relatively cheap pool boy job. And like hotels are going to be very specific, like much like how autonomous lawnmowers are a way more complicated project than people think, because like
you want it to cut cleanly and nicely.
In a golf course, you have to cut in a certain direction and blah, 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 blah. More so, the angle of the chairs is one of those weird, like we have to look good in travel magazines.
I'm just thinking because like if you controlled chair position, you'd know where the chairs are. And as you go back and forth returning towels, you just update your map with chair poses. So you know, like, because my point is you have to track.
You could issue an alert for like when, for example, the chair is too far out of the way.
Or something, right?
Well, let's talk about like how like ultrasounds in particular. Yeah, because I know this is your favorite piece of sensing technology.
Yeah.
So like, how would an ultrasonic sensor work like next to a pool while people are running around on the pavement? A surface that's sometimes wet, sometimes hot.
Yeah, absolutely. So the fundamentals of an ultrasound sensor is it sends out a small burst of high frequency sound, like it's basically a fancy speaker.
Yep.
And as soon as it sends out the burst of sound, it's usually an encoded burst, so it can tell apart its speaker from another speaker. It starts listening for the echo return, kind of like a bat.
Yeah.
And when it hears the echo, it stops its little timer and it knows the speed of sound in air, and therefore it knows the distance just by time. The problem with ultrasound is they send out a big cone of data. Yeah. And you can focus your speaker to be a little bit more linear, but basically it's still this kind of big, rough cone.
Yeah.
And so anything within that cone space will trigger a return.
Yeah.
And so the further out you are, the blurrier and blurrier your images in a data sense. The blurrier and blurrier your data gets because it gets bigger and bigger and bigger.
Yep.
So if
you're next to a pool that's essentially empty for 15 feet or whatever, and there's stuff on the other side, you have no idea what's on the other side.
No clue. I have 15
but it might
feet
not
for
matter.
Sure. It might not matter, but you'd need something like cliff sensors to make sure you don't fall into the pool.
Yep. Could you use ultrasounds for that?
You could. Ultrasounds do have a minimum range too.
Yeah.
Because speed of sound is reasonably fast.
Yep.
And when you excite the emitter, it takes time to calm down again.
Yeah.
So there's a minimum range.
So what's that minimum range time to look like?
I mean, it depends on the manufacturer, but 5-10 centimeters kind of range.
Okay.
So you can't put it right against the ground.
Yeah.
The fun part about ultrasound is that you suffer this problem where hard surfaces like ground and glass and stuff like that will bounce the sound away from you.
Mm-hmm.
And so if you're approaching the object in an oblique angle, you won't see it. You'll just smack into it.
So, for example, if the chair has been left out of whack because of my exclusion zone that I built around myself, it might become invisible.
Yeah, and so we'll bump into stuff. So ultrasounds kind of have fallen out of favor in robotics in recent time. They're still the most common ultrasound people run into is on their cars.
Yeah.
Most rear backup sensors are ultrasound.
Yep.
But having used those, I'm sure people have seen them before. You know how rough they are in terms of accuracy.
So at Starsky, we looked at ultrasounds that were, I don't know, roughly 2 inches tall. Maybe the edge of the cone was like an inch and a half wide.
Yeah, those are the standard automotive ones.
Yeah, and we were looking at them. We were putting them on like near where the headlights of the truck were to try to help us do obstacle avoidance while going through a toll plaza.
Yeah.
And this seemed like a really cool idea. And basically at the speed that, and I, my memory of this is blurry. This was an experiment that like we wrapped up very quickly. This was a cool idea for a week and it was completely shut down 2 weeks later. And essentially at the speed that we were driving, there was so much wind getting into the cones that the ultrasounds were just useless.
Yeah. Modern cars, they have these kind of solid ultrasounds and they're used for blind spot detection. And those have improved a little bit. But you do have a wind noise problem, and again, makes it a very rough estimate.
Yeah.
Like a lot of these car blind spot detectors, the ultrasound, and it's like, there's a car somewhere between 0.5 meter and 20 meters away. And like, that's your accuracy. So yeah, it'd be a robot that bumps into a lot of things.
So if we were driving this robot around the pool and the pool was, say, close to the beach where there was wind, would we be okay or would we be in trouble? Can you shield?
You can't. I mean, you can put some kind of foam material around. But the other problem, actually, the Astro program had at Amazon is that ultrasounds close to the ground see the ground a whole lot. So any little imperfection in the ground causes problems. This towel robot's probably going to be fairly beefy.
Yeah.
And so we can put them a little bit higher up. We can use them for basics, but...
I mean, imagine the towel robot can only be 24, 30 inches tall. I mean, it can't be
that's more than enough.
Okay.
That's way more than enough. But yeah, so it'd be an interesting kind of experiment. I think the ultrasound would be a last line of defense sensor for things like glass that other sensors don't see well.
Yep.
But... if it was only ultrasound, that would be a rough problem.
Yeah. So basically, if we're using ultrasound for this, we would need to have all the other sensors that we would normally use. Yeah. And then one has to wonder, why not just use those to see the things that we need ultrasound for?
Yeah. Yeah. Except for like transparent piece of glass or a mirror, which cause havoc for LiDAR or cameras.
People don't like much transparent glass on the ground at pools. That tends to be against the rule in the first place.
That sounds to be a bad idea.
So great. If this is a primarily ultrasound driven robot, well, maybe, to be honest, maybe we can use a pre-existing platform like a Jackal or something from ClearPath. Sure. Maybe we have a really cheapo robotic arm. Actually, I was actually thinking maybe we drag a trailer to dispense new towels, and then like we try to throw some old towels into the trailer on the way back. So it doesn't have to be that big, but like, given the limitations of ultrasound, we could have lots of ultrasounds and still need an ouster, still need some
cameras,
stereoscopic cameras.
Yeah. Localization for, GPS or whatever is a good cheat.
Yeah. So what's this robot cost?
If we made the arm really dead simple, because again, arms are going to be the biggest cost factor. Yeah. If it's literally just a claw,
we're going to have an upcoming episode in a little bit to give it some time from a conversation where we talk about arms. It's coming, don't you worry.
Yeah. So if it's just a claw on like 1 or 2 degrees of freedom, you could probably get away with like $5,000 ish.
$5,000 for the arm?
Just for the gripper part.
Yeah, just for the gripping part of the arm.
Yeah, like the arm assembly, let's call it, right?
So realistically, we're probably looking at a bill of materials $40,000 to $60,000 robot, maybe 30.
Yeah, 30 I think would be more reasonable.
30
in any kind of volume.
So if we're doing robots as a service, we'd probably want a 6-month payback. So that looks like $5,000 a month. So for only $5,000 a month, you can have the Towel Boy 3000. The Towel Boy 3000 is coming to resorts near you, primarily focused in countries that have low labor laws and relatively cheap labor. The Towel Boy 3000 can do all the tasks that your $3 per hour labor can do, but it costs more money.
And is worse.
But it does have ultrasounds, which is what it's all about. Alrighty, Ilia. So during one of our last blog posts, we got a comment saying, the best way to build a robot is hire a consultant to do it. And, as a SaaS-based robotics product, that's a little antithetical to our whole worldview. But why is it? There's a lot of people who worked on robotics. They're pretty smart. Can't we, they built it before. Why can't we just pay them to build it for us?
And to shape the conversation a little bit, when we say robot, we mean all the things that make a robot useful, not just the hardware, not just like the UI.
Well, obviously, I mean, I'm paying a lot of money for this.
Right.
I need an app to tell it what to do. That app needs to be designed for my workforce. It needs to be able to drive from point to point. It needs to probably do something with an arm along the way.
Whatever the task is.
And then build the arm and build the retrofit.
The reason I want to highlight it is because there are companies that specialize in developing just hardware.
Yep.
Like just a really good motor driver.
Which is a great place for people to do consulting work.
And like, great, here's a motor driver. It works within your spec. Yep. Here's the design files. Have a good day.
Or frankly, here's a vehicle. We've retrofit a bunch of vehicles before. It's going to take us some non-scalable engineering work to figure out how to retrofit this vehicle, pay us this much money so we can have a 50% margin on that work, and let's go.
Yeah, so that's not what we're talking about, because that does succeed reasonably well. What we are talking about is actually providing the robot itself to do some useful task.
Yeah.
And so that's really tough.
Yeah.
I think part of it has to do with the rapidly evolving nature of robotics currently.
Yeah, but that's true in every space in tech. You could say the same thing is like, why not that's why you can't use consultants for enterprise software, because enterprise software is coming out all the time. So like, why should you hire a consultant for a new SAP implementation?
So the difference with robotics is that we've seen such leaps and bounds in fundamental sensing and controls and actuators and machine learning and every part of the stack. The equivalent would be like somebody designed an SAP-like thing for IBM in the 80s, and then the year later, it was IBM in 2020. Like, that's the kind of, in the last decade, sort of leap we've seen.
See, I more think about it as this isn't a slag on consultants. This is actually more of just a comment on the state of robotics. And like, because it's not just that robotics consulting is a hard business. It's also that, frankly, robotics product management is a crappy discipline.
Robots are hard.
Yeah, robots are hard, and robots are hard to estimate how hard they are. I mean, like if you look at SaaS companies, basically every SaaS company underestimates their timelines by, 50%, 25%. Maybe if they're really bad, like they think things will take half as long as they actually take. In robotics, they're usually off by an order of magnitude. Like you'll have a team of people being like, yo, we're at Waymo. We know how to do this, this, and this. We're going to spin it all up. In 3 months, we're going to be as good as Waymo. In 9 months, we're going to break a bunch of world records. And, we're going to generalize all sorts of things by month 15. And then it turns out by like year 4, they're kind of barely anywhere noticeable.
I mean, the notable exception to this trend is Tesla's full self-driving, which came out in 2016 and has been perfectly operational since.
But listen, a lot of those people had worked on the product before, so it was easier.
Yeah, absolutely.
I mean, I think like I think I said the other day to somebody is like, the second robot you build is easier than the first, but the third isn't much easier than the second. Like it kind of like the rate of ease gets pretty limited in the current state of the state. And that's what I think is so hard. So like we at Polymath right now, we have a couple, we are so fortunate as to have multiple customers with massive deadlines in the next 10 days. And frankly, multiple customers whose deadlines have already been swooping past us, sometimes for our fault, sometimes for other people's fault, sometimes for the universe's fault. And we are playing catch up. We have worked the last 2 weekends fully. We're probably working this weekend full time. And I just gave the whole team a spiel about how maybe consider working really late tonight and doing the same tomorrow and basically until Tuesday. And I think like if you're a consulting firm, there's a weird conflict of interest that shows up. So like most consulting firms pay their employees a salary, charge their customers an hourly rate for the time their engineers spend. So had we just worked an extra 50 man hours per weekend for next weekend and last 3, we'd be due another 150 times consulting rate. And I, as CEO, would go be charging our customers that, and then having to rationalize why it took so long. And funny enough, us cramming over the weekend would make me more rich.
That's Stefan's ultimate goal.
Yes. Yeah. I mean, that's not a subtle goal, but there's this weird conflict of interest where like it actually kind of behooves me if I was a consulting CEO to want the team to be more cramming for things to work.
Yeah. And cramming in every discipline, but robotics and software in particular doesn't lead to good long-term reliable solutions. Really? Yeah, surprisingly, right? It worked so well in university, cramming right for an exam. I had perfect retention rate after that. So you kind of get caught in this trap where you're rushing to finish a project and your solutions are okay, but they're not reliable and they're not maintainable and they're not secure and they're not performant. And then you move on to the next project and you start the cycle all over again. And having to break out of that by not doing consulting projects is actually really important in robotics.
And also given how hard robotics is, if you're cramming a bunch of stuff together in the last couple of weeks to get something up and running, then it's very likely you have a product that no one's ever going to be able to figure out.
Yeah.
That even your team might look at in 3 to 6 months and say, how did that ever work? We are now screwed.
Yeah. Because the flip side, we've talked about this before, is that anytime you do a robot demo to non-roboticists, they're like, yeah, okay, that's fine. That was okay. That seemed interesting.
I mean, that robot moved. I've seen robots move before. How hard was it to make it move?
Yeah. And then the inevitable question is, okay, great. Well, when do we put this into production? And your stuff is not consulting projects and rushed projects in general don't create stuff that's reliable for production.
Yeah.
And so you really have to go back and actually take the time to tune it and to productize it and to make it releasable and maintainable.
And to build like metric systems where you know if the system's doing well or not doing well. And
Exactly.
Metrics are kind of a hard thing to pitch an end customer on.
Yeah.
Like if you think about like we have some really large customers we're very fortunate to have, and like they're not dumb. Like I could spend an hour or two explaining the value of us spending 100 man hours coming up with a Prometheus-like system for robot metrics, but that's going to be one of my harder sells ever. But from an engineering development perspective, it saves us lots and lots of time.
Exactly. And so you're kind of caught between these two things. It's very tempting to do consulting type work, both for the company itself and for the buyer, because it might look very attractive,
especially if they have a fixed price and then they have a robot that just works forever and they can amortize over 50,000 years.
Yeah, that's how robotics works. Don't have to maintain it, don't have to update it. It just build the software once and never change it. But no, so that's really, it's tempting both from the buyer side, it's tempting from the engineering side, and it looks good in the short term.
Yeah.
And that's really what makes it so hard to fight against in a lot of ways.
So I think this reminds me of many, many years ago, I like had someone pitched me on SaaS like in college. And it like was so weird as an idea to me. Basically, I had a college internship where we implemented SAP, and it was a stupidly expensive implementation. It was like it was a $250 million a year company buying SAP for a $500 million a year company. They're buying a particular version. It was going to be version locked forever. They're going to spend like $50 million on consultants to set it up. They're going to spend like $50 million on the license, and then like $10 million a year on like maintenance for their particular instance. And then a couple years later, I had an interview like my senior year of college for a big like EHR company called Epic, which if you know people in the medical field, they mostly hate Epic. But the reason why Epic has been like by far the most successful EHR is it's recurring SaaS and everything's the same version. And I remember like asking the guy like dumbfounded, like, well, why don't you guys sell a new version of the software every year? Why are you like maintaining an old one? And a big part of the thought process, and like the thought process basic to all SaaS, is it's easier for us to maintain one version than 10,000. It's easier for us to build a great software engineering organization if most of our engineers are just focused on making our product not suck than if they're getting billed per hour for fixing spaghetti code somebody wrote like 3 years ago. If they're fixing spaghetti code, they should fix it across the entire board and not just for this one hospital at this one place.
Yeah, you never want the like, oh, where's your source code that we can connect to? Oh, here's a zip file on a Microsoft SharePoint. Specifically SharePoint. It's always SharePoint. Here's a link to SharePoint with our zip file of our code. Oh, when was it last updated? 4 years ago. Okay. By the way, it's version locked to a particular compiler. Okay.
Yep. I mean, I think what's interesting about the kind of broader like SaaS market is part of why it did so well in the last 10 years was this realization of the economies of scale you can get when every engineer in your company is maintaining the same product. Yeah. And like, in fact, then how much more venture backable that software is. If like we're building one thing, we might use feature flags or something to turn off functionality for people who pay less money, but we're building one thing. Every customer gets it, and all of our engineering effort goes into making sure this one thing works. That's frankly why software doesn't suck today like it did in 2005 and 2000. Like all that stuff was just terrible back then and impossible to use. Whereas now there's a whole industry, there's industries upon industries to make sure you're happy with your recurring payment SaaS product. Because if you ever stop being happy, you stop paying.
Yeah, exactly. And I can almost hear my robotic founder colleagues kind of thinking like, oh, but I'm working on a particular robot. I'm working on a floor cleaning robot, like an iRobot.
Yep.
This doesn't apply to me. It does. The modern iRobots are completely different than stuff 4 years ago and are in a different galaxy from stuff when they first started.
Yep.
Right. Totally different everything. Different sensors, different compute, different everything. And they still do have to support the manufacturing and sales and repairs.
And the hardware stuff is still hard. I mean, I think part of why...
No, but even pure software, right? Yeah. Like the compiler for their modern stuff, totally different.
So I guess my point is more, there's an easy rationale in robotics of like, let's not move to SaaS or RaaS, because like hardware is still the bulk of our cost center and the bulk of what's hard to change. And like people want hardware, so they're willing to pay for hardware and blah, 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 blah. And that just leads to a hard situation.
Yeah. You're making your life much more challenging. B, you're kind of forgetting this golden rule that we keep harping on, is that people buy robots and businesses succeed despite the robots. It's very rare that the robot is kind of the key thing that makes whatever business work, right? It's a optimization, it's an efficiency gain, it's a whatever, right? And if you're not being more efficient, if you're being more expensive, your robot's not going to go anywhere.
Or if you're requiring massive CapEx and then you have to charge a whole bunch of money every time that you want a little bit more functionality. Like, I mean, another lovely thing about SaaS is SaaS companies can continue to delight you with new features after you've bought them.
Yeah.
And that's
for sure
really cool. Like, oh, your e-signature app now tells you when people view your contract. And that can be and they just released an integration to your CRM so that your salesperson can get a ping in their CRM when people are looking at their contract and use that to pretend they have a better sense of when the deal is going to close. That's a delightful little thing that makes people happy to shell out their $10 a month for an e-signature thing.
Exactly. Yeah. And same with robots, right? We've talked about this before, but with the evolving state of software and robotics, you can improve your machine learning models to be more accurate. You can improve your controls. You can do all these things that don't look like anything to the customer, but make performance better.
Or like a neat thing that I just got asked about by an investor, you could, as a gag, integrate with ChatGPT so that ChatGPT can issue an API command so that your robot does something when somebody says something with their voice or types into a field. They could type something not magical into a field, and then boom, your robot does something magical. And that technology probably didn't exist when you designed your robot 7 years ago. However, if you build yourself flexibly as a high quality software product, that's kind of a free feature to ship and delight your customers. Whereas that might be another significant consulting project.
So it's better for your customers. It's better for your engineering team. It's overall not doing the consulting thing, but actually building a product.
Yep.
Right? It's better revenue-wise in the long term. It's more predictable. What are the downsides
from not doing consulting stuff?
Yeah.
I mean, you get asked to do consulting stuff a lot. People say like, oh, hey, like, I mean, it's not been uncommon that I've tried to go sell some polymaths to somebody that said, oh, what if you just solve general perception for us? And that could, fund a month of runway or several months.
It's very tempting as a founder, right? It's very tempting to take that.
It's like crack.
Yeah.
You shouldn't do it.
Hot take from Stefan.
But I guess like you just brought it up from a robotics team side.
Yeah, exactly.
From a market side, from a customer side, why shouldn't they hire some hotshot group of consultants to solve all their robotics problems for them?
Yeah, it's the thing we've kind of been talking about. Best case scenario, the consulting group does an excellent demo.
Mm-hmm.
Fantastic. But
On budget.
On budget.
Yep.
On budget, on time, fantastic demo. Excellent. That's already the top 5% of outcomes.
Yep.
Great. Now you have a great demo app. Actually shipping
and
you
have a demo that everyone around you thinks is real because they're used to software demos equaling reality.
Exactly. And so now it's okay, now take what they've produced and actually try to productize it and make it reliable and make it robust and
it turns
secure.
out their documentation is probably not good enough for you to do that. It turns out you probably hired a consulting firm because you don't have the internal resources to do that. It turns out a whole bunch of things are suddenly not solved.
So your best case scenario is a shiny demo, which doesn't impress anyone because this is robotics. That's the best you can hope for.
And it's probably not cheap.
And it's not cheap. So if that's what you're going for, great. But and some companies need that. You know, you go to conferences, you need a shiny demo. We're building a shiny demo. It's for fun.
Yep.
But you know, if you're expecting a product, not the way to go.
Yep. And in fact, shiny demos are easier to ship if you have a good underlying product.
Oh yeah.
Funny how that works.
Exactly.
Ilia just popped out a really cool shiny demo for us in the course of the last 2 weekends, and it's really cool. Yeah, we'll probably show some videos of it online the next couple of weeks. It's really shiny. It's not really a product.
Yeah, exactly. It's
what about below the 95th percentile?
Yeah, so we'll show off that demo at Con Expo. We're going to be there next week with our hardware partners, Hardline. And Con Expo is a conference for
the construction industry, people
yeah.
who like construction equipment, like the mining industry.
Yeah, exactly.
A whole bunch of these folks. We are going to be launching a product there, but I can't tell you what it is because it's still not public. So buy your tickets to Con Expo today and stop by our booth with Hardline Systems, or just, read the news on Monday or Tuesday.
If you have your inner 5-year-old who loves playing with like construction equipment toys.
Yep.
That, but real and huge. So that's the really fun part. So yeah, come check out our booth, drop us a line, come chat with us.
Well, but sorry, getting back to it, what happens in the sub 95th percentile of robotics consultants?
Yeah. You're over budget, you're late.
Yep.
Your system doesn't work very well.
Yep.
Or it works only for a very narrowly defined thing.
Yep.
And you have to pay extra for change requests or design requests. It works for 1 unit, but not 3 units. Like that.
And a lot of this comes from the fact that it's so hard to scope out robotics. Like I don't.
Yeah,
like,
this is not insulting consultants. To be clear,
yeah,
right?
Absolutely.
This is the nature of the beast of robots.
Yep.
Right. It is an extremely hard, poorly defined, rapidly evolving field.
There's a deal that we lost. It was the first deal that we ever quoted where we learned that the other folks that they were talking to were consulting firms. So I figured that we'd look like, everyone else's quote would come in at low 7 figures. So we quoted like high 6 figures to not look like a loser. One of the consulting firms quoted like slightly lower 6 figures than we did and won the deal. I caught up with a team, 6 to 18 months later, where I kept on catching up with them. They haven't seen anything yet.
Yeah.
They don't. And in fact,
this was the first thing we did as Polymath Robotics.
Yeah, we were like
before we even had a test track.
We were like 2 months into the company.
Yeah.
I was just like making up pricing numbers because I didn't want to look like a loser. And we cost way less now, just for anyone listening. But we essentially, it seems like they dropped the project because they already went over budget by some amount and have yet to show anything.
Yeah. And in that time, we've shipped several, different robots that are working in the field. Also, obviously, we're a startup. It's developing field. It's not perfect, but like we got something moving around.
Yeah, and the challenge here is that like the consultants made a really good pitch. They scoped it out really strategically to win the overall project, but they didn't deliver. So they made money, but they left an unhappy customer.
Yeah, and you can only do that so many times,
which is a hard thing we've seen in the space. But regardless,
on that note, Stefan, what are we talking about this week?
You got me. So next week we're going to be traveling. Our producer is waving her arms in the air like an airplane.
Yeah, airplanes are known to flap.
Yeah. I should know this episode of the podcast is sponsored by friends who casually mention they're into mixology, and then you take advantage of that to make them make you a martini before your podcast. But we will be on the road next week at Con Expo, so please visit us if you'll be around. And
unlikely to release an episode next week.
Unlikely, but not 0% chance, just low 20%.
Yeah.
On that note, thank you so much for joining us for this rambling and bambling 25 to 45 minutes.
See you next time.